everyone, so today we're going to be going over 4-6 graphs of tangent, cotangent, cosecant, and secant. So I know we've all really been looking forward to this day. We're wondering, okay, I know what sine and cosine look like. What do tangent, cotangent, and cosecant and secant look like? So we're going to answer those questions today. All right, we're going to go ahead and start with the tangent function. So what I want you guys to do if you have your unit circles is go ahead and get them out. We're going to use them to make a table, just like we did with sine and cosine, to establish what tangent is going to be. We need to remember once again that tangent is always equal to the y value. So we'll say tangent of theta is equal to the y value over the x value. A couple other things that I want to do first is that the x-axis, just like in sine and cosine, is going to represent theta, not my best theta, and that the y-axis is actually going to represent the y over x value, which sounds crazy, but we'll get it soon. So the y over x value is the y-axis, theta is the x-axis. Let's go ahead and figure out what's going on here. All right, so in our table, let's go ahead and put some theta values. Let's say maybe theta is 0. Let's say maybe pi over 4 and pi over 2, 3 pi over 4, and lastly pi. And you'll see why these are a little bit different this time. And I want to evaluate tangent at each of these. So first one, I want to know what is tangent of theta at 0. Okay, to establish what that is on my unit circle, I need to know what that ordered pair is. So tangent of theta at 0, well, that's going to be the ordered pair 1, 0. And remember that tangent of theta is equal to y over x. So in this case, the y value is 0, and the x value is 1. So 0 over 1 equals 0. So tangent of theta at 0 must be 0. So let's go ahead and put a big old dot at 0, 0. Next one, pi over 4. Okay, at pi over 4, our ordered pairs are radical 2 over 2 over radical 2 over 2. Okay, so the y over x value must be radical 2 over 2 divided by radical 2 over 2, which sounds crazy, but the same thing over the same thing is 1. And so therefore, at pi over 4, which we will label on here, at pi over 4, we should be up 1. And just so you guys can see this better, I'm going to scale 1 up a little bit higher. Okay, so let's go ahead and figure out the next one. I want to know what's tangent of pi over 2. Okay, well, tangent of pi over 2 is going to be the ordered pair 0, 1. So y over x in this case is going to be the y value, which is 1, divided by the x value, which is 0. But 1 over 0 is not defined. In fact, a really quick way of remembering that, a number over 0 says no, don't do it. But if you have 0 over a number, it says on, and on is fine. So that's a quick reminder there. We'll talk about why 0 can't be a divider later, but we're just going to say that's undefined. So we have no idea what that value is. In fact, we're going to go ahead and sketch an asymptote there, roughly at pi over 2. So go ahead and sketch what's called an asymptote. You could do a little dot, dot, dot if you wanted to, like this. We're going to talk about what that means, the fact that tangent is undefined there. So here's what it means. If tangent is undefined, it means that basically the slope is undefined there. In essence, at the ordered pair 0, 1, I have 1 divided by 0. So basically what we're saying is that we're going up maybe 1 and we're going over 0, which is no different than going up infinity and moving 0. And so we can actually say that there's what's called a vertical asymptote here, which we will discuss again when I come back to class tomorrow. Okay, so let's keep the pattern moving. The next value, let's try 3 pi over 4. At 3 pi over 4, our ordered pair is negative radical 2 over 2, radical 2 over 2. So if I say negative radical 2 over 2 divided by radical 2 over 2, I'm going to get negative 1. And so that means that at 3 pi over 4, I'm going to get negative 1, like this. All right, so that's our new ordered pair. Let's continue. If we go over to pi, our ordered pair is going to be negative 1, 0. And tangent is going to be y over x, which means we're going to get 0 over negative 1, and we get 0. Okay, so we're maybe seeing a pattern here. Let's go a little bit farther. Let's say we go all the way to 5 pi over 4 now. So if we do 5 pi over 4, that's down here. Its ordered pair is negative radical 2 over 2, comma negative radical 2 over 2. If I divide those things, negative radical 2 over 2 divided by itself, we're going to actually get positive 1. Okay, so we're going to get positive 1 here. All right, so hopefully we're starting to see a little bit of pattern. I'm actually going to finish the pattern going to the left and right here. So let's go ahead and finish this pattern. Okay, so if you see the pattern, great. If not, I'm going to show it to you. And we're going to get another undefined here at negative pi over 2. Okay. All right, so here's our pattern. I'm going to go ahead and complete this by sketching. So we can see here that there is some sort of pattern going on here. It looks like it actually only consists of about 3 to 5 points if you're counting the asymptotes. And we can see that the tangent, just like sine and cosine, is cyclical. Here's what it looks like if we complete the sketch using a smooth curve. It's going to look something like this. Okay? So we can see that tangent is much quicker than the sine graph. It's a lot skinnier, like it repeats a lot faster than the sine graph. And it actually contains 2 asymptotes. And the reason it does is because if we have a number divided by 0, we're going to get an asymptote. So let's go ahead and define some key characteristics here. Let's first talk about the period. The period is going to be how long the graph takes to start over. So let's see. We went pi over 4 plus another pi over 4 plus another pi over 4 plus another pi over 4. That's 4 pi over 4, which actually simplifies to pi. And so we can see, actually, this is interesting. The period for tangent is not 2 pi, it is pi. Okay, so that's interesting. So the period for tangent is pi. We can also see the amplitude's a little bit different here. It goes up towards infinity and down towards negative infinity, so our amplitude value is a little bit different. We're going to say our amplitude value has to do with this point here and this point here. Or you could say this point here and this point here. This is how much I'm going up from the midline after one quadrant line. So you guys can see after one quadrant line, how much am I going up from the midline? We can see that's 1 and 1. And so in this case, we can say the amplitude, which is a lot different here, is going to be 1. In fact, I might not even call it the amplitude at this point. It's just an A value or a vertical stretch value. Some other things that I might want to discuss here. So we talked about period, we talked about amplitude. Is something kind of new here, which are the asymptote values. So you guys can see that the asymptotes are happening at pi over 2. They're happening at negative pi over 2. And if we continue this pattern, we can see if we continue this a little bit farther, they're happening at 3 pi over 2. And actually, if you continue, they happen at negative pi over 2 too. So let's go ahead and define this. We can say that the asymptotes are happening in a pattern too. So let's go ahead and define the asymptotes here. Our asymptotes are basically happening every increment of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc., etc. So in order to define this, we can actually say that the asymptotes happen at pi over 2 times some integer n. And we'll get more into this later, and depending on if you're in honors or regular, we'll discuss it more. If we're in honors, we'll discuss it more. If you're in regular, maybe we can forget it. But this basically says that asymptotes are happening in increments of pi over 2. So n could be really anything. N could be 2, and if n is 2, then we're going to get pi, etc., etc., except I need to change this just a little bit. It's pi over 2 plus n. There we go. That makes a little bit more sense because we can't multiply. We'd get pi, which is not an asymptote. Okay, so this is basically everything we need to know for the tangent function. And I am going to be doing a memory quiz over the tangent function. The tangent function's memory quiz is going to be a lot easier than the traditional sine and cosine quizzes because there's just less to graph here. So on your memory quiz, you guys are going to be responsible for this asymptote here. You're going to be responsible for all of the quadrants, so pi over 2, pi over 4, 0, etc. These right here. These points right here, and this asymptote right here. So basically 2 asymptotes, 3 points, and 4 quadrant labelings, and then also the vertical labelings. Okay, so let's go ahead and we're going to talk next about the reciprocal of tangent, cotangent. Cotangent is going to work a lot similarly to this, so we're going to try to expedite the process just a little bit. We'll still make our table, but we'll just go a little bit faster. So remember that cotangent of theta is going to be equal to the reciprocal of tangent. So instead of y over x, it's going to be, okay, so let's go ahead and start by creating this. Remember that cotangent is x over y. So using our little xy table, we're going to go a little bit quicker this time. We're going to go ahead and do some key values. Let's start with 0. We'll do pi over 4. We'll do pi over 2. And maybe we'll do 3 pi over 4. Okay, so according to my unit circle, which you guys should probably have handy, I want to know what's the cotangent of 0. Okay, well, cotangent of 0 is basically saying what is the x over y value at 0. So this is going to be the ordered pair. It's going to be the ordered pair 1, 0. And so x is 1, y is 0, and 1 over 0 is undefined. And therefore, we're going to go ahead and sketch a vertical asymptote there. So if we get undefined, we're going to go and sketch a vertical asymptote. Okay, let's keep moving. Pi over 4. That's the ordered pair radical 2 over 2, radical 2 over 2. So x over y here is going to be x, which is radical 2 over 2, divided by y, radical 2 over 2, and that's equal to 1. So at pi over 4, we're going to go up to 1. Okay, let's keep going. At pi over 2, that's the ordered pair 0, 1. X is going to be 0, y is 1, and 0 over 1 is 0. And so what we're going to get here is that at pi over 2, we should be at 0. Let's go over to the next one. We have negative radical 2 over 2, radical 2 over 2. X over y in this case is going to be negative radical 2 over 2 divided by radical 2 over 2, which cancels to negative 1. So at 3 pi over 4, we should be down here at negative 1. Okay, very last one, which I suppose we ran out of room for, so let me make some room real quick. Let's go to pi. Okay, so let's go ahead and figure out what would pi be. Okay, well at pi, our ordered pair is going to be negative 1, 0. And so x is going to be negative 1, y is 0. So x over y is negative 1 over 0, which once again is undefined, which means we're going to put an asymptote there. So at pi, we should be undefined like this. If I sketch this with a smooth curve, we should get a graph that looks something like this. And this is the cotangent graph. Notice here how once again, the cotangent graph has a period of pi. And the a value, which I'd say is more like a stretch value, not necessarily amplitude, you can see that, look, this goes up a distance of 1 from the midline. And then this goes up a distance of 1 from the midline. Okay, so some key takeaways that I want to talk about. Remember, this is still on your memory quiz, so I might give you cotangent, I might give you tangent. You would be responsible for this asymptote, this point, this point, this point, this asymptote, this labeling, this labeling, this labeling, this, and this. Okay, so let's go ahead and do some key takeaways for cotangent and tangent. All right, so some generic ways to write cotangent and tangent is very similar to sine and cosine. We can say A, tangent of bx plus c plus d, or say the same thing with cotangent. So go ahead and write this down. When you're done writing this down, I want to note some really specific things here, some things that are really, really important if you want to be successful with cotangent and tangent. The most important thing here is that period, normally with sine and cosine, was 2 pi over b, but because the baseline period for cotangent and tangent is pi, we know period is actually going to be pi over b, not 2 pi over b, specifically for cotangent and tangent. So that's something different here we need to keep in mind. And remember, the b value is still the same value here. Everything else is going to work the same. A is still going to represent kind of an amplitude. I wouldn't really call it that. I'd maybe call it more like a stretch or a shrink. We can call it a stretch slash a shrink value. That's A, right? Or compression value. It's kind of like amplitude, but not quite. We know that all of bx plus c, just like last time, If you set all of bx plus c equal to 0, you will find the phase shift or the left and right shift. And lastly, this one's pretty easy. The d value is always going to tell us up and down shift. So we're going to say the d value here, that's always vertical shift. Okay, so that's pretty much it for today. I want you guys to kind of start working on memorizing the cotangent and tangent graph. And you also need to remember that the period is going to be a little different in this section. The period of cotangent and tangent is pi over b, not 2 pi over b. Okay, you might be able to get a little bit of your web assign done also, but that is going to be it for today.